and every one of you at your various capacity to today's ProDev Hour. And I would like to say that last week we had a very fruitful discussion as we started looking at the assessment strategies for our learners at upper secondary curriculum. We are all aware that UNEB has released the sample strategies, sample assessment papers. And we had Mr. Kakuru Bernard who took us through general session, and he was able to concentrate greatly on ICT assessment. So we decided that at least we should be inviting different subjects every feel this Mr. Ochan Nelson, who is a competency-based curriculum facilitator for chemistry. Nelson is a teacher of biology and chemistry. We trust in his abilities. He has vast experience, and in this evening is going to share with us his experience, especially on chemistry. I therefore would like to invite all of us and welcome Nelson to come and share with us what he has. Mr. Ochan Nelson, you are most welcome. You can take up the floor. Thank you very much.
Thank you very much, Madam Betty. My name is Ochan Nelson, a teacher of bio and chemistry with a lot of specialization, that is in chemistry.
Mr. Nelson, hearing me?
Yes, I can hear you very clearly. Can you hear me clearly? Can you hear me clearly?
Can hear you, please. You proceed.
Yeah, I was saying my name is Ochan Nelson, a teacher of bio and chemistry with much focus that is on chemistry. Today, I would like to share that is the chemistry and CDC assessment framework, and that is the structure of the UNEB UACE 2026, that is the sample papers. But today, I want us to narrow down and look at basically on the basics, that is on how chemistry paper 1 is set at advanced level, the learner's task, and the task that teachers should take so that we can maximize the outcome of these results. Because if we don't do that, then we would have left our role as educators, we would have left our role as teachers if we don't guide on our expectation from the assessment framework. Now, today, on my presentation here, we're going to be so intentional with it. On our table of content, what I will try to emphasize, put emphasis much on number 1. I want to put emphasis on the UACE chemistry paper structure, that is structure of P525, that is paper 1, stroke 1, paper 1. The second concept in our content, or what I will still go through, that is guidance, that is to approach on item number 1, that is which focuses or which assesses, that is the physical chemistry. Aspect number 3, I will also take you through, that is the guidance on approach and accessible areas on item number 2, still on physical chemistry. Then I will also take you through that is guidance to approach on item number 3, stroke 4. This is item 3 and 4. Item number 3 and item number 4, still on inorganic chemistry. Then guidance to approach on item 5 and 6, that is on organic chemistry. Now, without wasting a lot of time, allow me start with, that is with the paper structure, that is the paper structure of the theory paper with the paper code of, that is P525, that's stroke 1. Now, at section A, of the recent release sample papers and basing that is on the accessible guidelines. That's what were earlier released by, that is on the NCDC document. You can realize that section A, we are supposed to have 2 compulsory items, which are all supposed to come from physical chemistry. But out of these 2 items, they're coming from they're coming from a fusion of quite a good number of topics. So each item will fuse, that is 2 to 3 topics into a single scenario. So it might not be a similar case as we have been seeing in the previous content-based curriculum. So we might realize that a single scenario is going to have more than 2 topics. It might have 2 topics or can have 3 topics. If you find the one with 1, still you might find a lot of things might have gone through that is its development, and therefore we can still have time to adjust and make it a better scenario over the time. Now, so what is your role as a teacher here? Your role as a teacher is to ensure students can understand and relate some of these topics which are assessed under the physical chemistry. The beauty with it, the items are clearly defined that we have this set under this context. So we have item number 1, which I told you already. Item number 1 coming from thermochemistry, coming from chemokinetics, coming from electrochemistry. So meaning, in the context of item number 1, the question will come, but when said and fusing thermochemistry, chemokinetics, electrochemistry. So you might find a question having thermochemistry and maybe electrochemistry. A question fused between chemokinetics and electrochemistry. Maybe the one fused like the UNEB sample paper you saw, where that fused up, that is chemokinetics and thermochemistry. So that's what we are going to be having. Those are the scenarios we are going to be having in most of these settings. Item number 2, which is going to be coming from, that is equilibria 1. You have the topics of equilibria 1, topics like the chemical equilibria, ionic equilibria, the solubility equilibria. All those ideas will be coming under item number 2. Equilibria 2 covering topics like the physical equilibria, where that's where you have the phase and physical equilibria. We have corrigative properties, that's relative low vapor pressure, boiling point elevation, freezing point, depression, osmotic pressure of solution. All those are going to be accessible areas under item number 2. Then we have moles and equations. So meaning, at the end of the day, we shall end up integrating some serious calculation to assess how much quantity of these substances can be used at a given society level or at a given industrial context. This is the basics of section A. Moving away from that, we still have, that is section B. Section B, as can check in here. As can check in here, section B still of the theory paper, which is the paper 1, P525/1, paper 1. Section B is going to be derived from, that is from 2 branches of chemistry. Section A, we shall be having strictly physical chemistry. Section B, we shall be deriving it from 2 branches of chemistry, but we shall subdivide it into parts, as you have seen with quite a good number of mock papers and sample papers you have. But if you check in here clearly, the first part of section B, that is part 1, it is having the inorganic chemistry. 2 items will be set from this section, and learner is expected to attempt only 1 item or to respond to only 1 item from the inorganic chemistry. Then we have, that is part 2, having, that is the organic chemistry, and you are required to pick, a learner will be required to pick only one item from this section. However, reading the instruction might be very important, because now we might not be able to tell you all the aspects that I pick one. At the end of the day, reading the question become a very important concept in this idea. So as we proceed on this, it means a total of 4 items will be set in section B, where you're going to pick only 2, but 2 items, 1 item from each part. What are the coverage, or what are topic scope? What are the accessible areas in item 3 and item number 4, which is the section B, or the part within organic chemistry? All the topics, the periodicity 1, running with periodic trends and period 3 and the diagonalization, all those aspects are going to be assessed. That is under inorganic chemistry. So we have the periodic trends, we have period 3 elements and diagonal relationship, we have group 2 elements, we have group 4 elements, group 7 elements, and transition metal elements. I'm going to subdivide this with time where need be, then we see how best we can also break down, and we see how easy it will make our work be as teachers on guiding, that is, the learners. Then we have, that is, item 5 and 6, which will be coming from part 2, that is of organic chemistry. So on part 2 of the organic chemistry, we shall be having, that is, introduction to organic chemistry. We shall cover the assessment of hydrocarbons, that is alkenes and alkynes. Halogen alkenes, or what called the alkyl halides, will be accessible area, and organic chemistry, aromatic compounds, all those ideas which are folic and organic 1. Then all the topics of organic 2, still we shall assess them: alcohols, phenols, alcohol and phenols. We have carbonyl compounds, carboxylic acids and their derivatives, amines, then polymers and polymerization, and applied organic chemistry. So this is basic, the structure of this paper. Section A, physical, 2 compulsory items, pick all. Section B, having 2 parts. Part 1, having inorganic, you pick 1. Part 2, having organic, you pick 1. But now, as I proceed, you will discover that there are a lot we have to do with. Now, what are the basics of setting of these items? What are the actual verbs that they use in setting of these items? You will be given data. You will be given data involving a given chemical process. For example, in section A, you'll be given enough data, which is a cross-cutting data. You're given a data to analyze, and the question will not be low order thinking question. They're going to be high order thinking question. Questions will ask you in both parts to analyze. Question will ask you to evaluate. A question might ask you to justify. The question will ask you a higher order question, which you might need to synthesize and know how best to answer them. And now that's why the concept of guidance, of what to know on how to guide learners, become very, very, very important. What should we do as educators? What is our role as teachers in guiding the learners? What should we tell them? What should they know on how to respond to these items? Otherwise, if we don't tell them how to respond to high order thinking question, then we would have entered problems as educators. We would have not done our role. We would have allowed learners to do what they would think is right. But at also as another expense, we can't give them everything. They also have to take time and analyze what is supposed to be right. Now, I'm going to give an example. I'm going to share an example in here of one of the papers here, then we try to see. I'm going to start in here with, I'm going to share in here an example here, like of the UNEB sample paper, the recent UNEB sample paper that was released in late June. We have in here, that is, we have in here with us here, we have in here UNEB sample paper, chemistry paper 1. So the question which was provided in here had two topics combined. They combine, that is thermochemistry, and they combine, that is chemokinetics. So as I was telling you, the kind of questions we are going to be having in here, we shall be having question, the task, or the task each item is supposed to carry. We are going to be having tasks which require learners to analyze a given observation or to analyze a given set of data provided. So, but in this context, now that's where my role starts today. I'm supposed to guide you on what we should do when the question is requiring you to analyze the observation made during data provided, assess the ways through which the use of methane as a fuel can be maximized with reference to data in table 2. Those are basically how the task will be coming in form of a high order thinking question. So then we have another one in here of assess. You might be having question of assess, analyze. How are we going to deal with questions of assess? What are we supposed to deal with? Assess the seller's concern, evaluate the impact of additives to human life. Basics of item number 2. We have in here still item number 3 in here. Question requiring you to analyze the observation you have made during this study. Justify the responses provided by the tour guide. So, meaning you can be given maybe a given concept or maybe a given recommendation, and you are supposed to justify it, whether can be valid or whether might be important in what is respected to her. So, all those aspects of higher order thinking question, meaning we might not expect a lot to see question like state, define, question like outline, question like explain, question like describe. We might not have them because those were relatively lower order thinking questions that they were not familiar with or that they did a lot of work on already in O-level. We have another question in here. Analyze the properties of the material and their interaction with the environment to enable the learners to select the best material for the bridge. Assess the impact of these materials on the environment. So you can do environmental assessment on the impacts of material, and all these items, I'm going to guide on them on how best we can approach them. We have in here analyzed the observation made by John about the waste collected from the drainage channels. Analyze the reactions of the synthesis of plastics, Q and Y, and those highlighted in the scenario. Evaluate the impact. So what will be our role when the question wants you to evaluate? So all those we are supposed to be guided on that. Then we have another one in here. We have another one in here. If I would share it still, we have another one in here. We have another paper in here. I picked another paper that I thought would be more important. That is of the Science Educator Examination Board that I picked, and I want us to use it here for referencing, not for criticizing, for referencing and for learning, purpose of learning. That's why giving positive comments on some of these papers would make a lot of sense for us. That's why if you find a mock paper that would like to share us with idea after some time when we give you space, it would also be more important if you could see them. We have still task here or prepare a report addressing that's the management concern using that information provided. This is a high order thinking question that you need enough information to do with them. We have another one in here, a question telling you to analyze the quality control. Analyze the quality control laboratory data, analyze the quality control laboratory data to explain why the solvent losses occur. Evaluate the suitability of methanoic acid formation for maintaining, that is, a stable pH, and explain other application of the similar system. Now, all these are items we are supposed to be exposed to, or these are basics of how these items are going to appear in form of high order thinking question. Now, what is your role as a What will be your role as a chemistry educator? What is your role as a chemistry teacher? Your role will be guiding the students on what to do. Your role, you are supposed to know how these items are set. You should be knowing the basics of how these items are set, how we can pick them from the syllabus book and set them from a given learning outcome. Otherwise, we are going to set items which have very many parameters that learners cannot analyze. We are going to set items that have fewer parameters that learners can analyze very easily and they don't attain the competence, or vice versa. Now, I separated in here, uh, I separated in here how to deal with item number one and item number two because they don't have the same requirement. We have guidance here on item number one, which assesses that is electrochemistry, uh, thermochemistry, and chemokinetics. As you can check with most of the data you have observed, you have seen quite a good number of sets of papers. You have seen quite a good set of number of mocks asking you to assess, asking you to analyze. What are you going to do with it? What should you guide learners on? So when you have a question like of analyze, assess, examine, all those concept or all those high order techniques of how to examine the items, we shall deal with them in almost in a similar way. The question wanted to analyze, the question wanted to assess, the question wanted to examine. So we shall assess them almost in the same way. So in that context, you are supposed to teach learners or you are supposed to direct them to examine the data provided very well. After looking at the data, could either be in terms of a table, could have been a graph, can be a statement. Like for example, in section B, can be a statement. But in this context, section A, we're dealing with major tabular data and maybe graphs. So you are expected to examine the data and be in terms of what? You are supposed to identify the chemical process and the chemical principle that is controlling that chemical process presented in the scenario. Now, for example, we might be having, like for example, in the case of UNEB sample paper on item 1, where the chemical process was basically that's about the combustion and decomposition. Those were the chemical processes. But what is controlling? What chemical principle is controlling them? The Leketlius principle, really controlling them, that if at all the concentration of the reactant decrease, it means in this context, you're going to get low amount of the products in that respect. We have decomposition, you're decreasing, that is the amount of the products you're using in burning, or the methane. Meaning, in this context, you're supposed to identify clearly what you're supposed to talk about. Identify a given area and see what is controlling it. It becomes very easy to answer. Number 2, you're supposed to carry out the data analysis by performing calculation. Data analysis, you might be doing a lot of calculation or plotting graphs on the provided data to determine how that data is related, that is to the chemical process and the governing principle being examined in the scenario. That is for the concept of assess. Aspect number three. The question might be asking you to justify, to evaluate, to explain how a given process can be maximized. So in that context, you are supposed to go ahead and explain your observation and deduce implication, giving us the conclusion regarding that chemical principle. How best can that process be improved, or how best can we maximize, that is the product formation or that given system, or how best can we manipulate concentration, how can we manipulate temperature, such that we can come up with that with maximum yield? How can we improve best? How can we best design that system, come up best with the maximum yield? Like for example, I would like to check in here with this UNEB sample paper that is on item 1. Then I check also with the rest. You realize that if I'm to share up this paper, you realize that the basics of what I'm talking about here become very, very, very clear on what we are supposed to do. Now, for example, in here, we have in here the sample paper here. If I'm to try to scroll up here, let me scroll up and see. We have in the sample paper here, which was saying the use of alternative energy sources other than firewood is being encouraged by the government as a way of reducing deforestation. A farmer in one of the districts started making, that is biogas, from waste materials as a source of energy, stroke fuel for cooking. A few days later, the farmer made the following observation. There was a lot of heat produced from the biodigester pit. Whenever she adds waste matter to the pit every month, the gas production is high, but by the time she adds again the following month, the gas production has reduced. So meaning, this is a clear indicator that you should be looking at, that the concentration of reactant is the one driving all these changes. So then there's reduction amount of gas produced, which increases cooking time. You know the concept of combustion, that if at all you reduce on the amount of reactant, it means less heat will be produced from the combustion reaction. So you should be knowing that the given chemical process here, like for example, we are seeing in here combustion and decomposition, anaerobic decomposition, which is producing that is the methane. You should be clearly knowing them that they are being affected, that these processes in here, decomposition being affected by the amount of reactant, combustion being affected by amount of reactant. So you should be knowing that the factor being examined in here, they examine you the factor of concentration. Then you should be knowing that the governing principle behind it. So the farmer got concerned about the observation and seeking for an explanation, the information table 1 and 2, about the information on methane from glucose and that. So we have an equation here for formation of methane from glucose by decomposition. Then we have table 2, which is showing data for the combustion of methane. So now, the rate equation for the combustion methane will also be required. So meaning, they already guided you on what to do and the hint of doing the question. Analyze the observation made using data provided. So meaning, in this task, you have already discovered that what you are supposed to explain as a student, you are supposed to explain how the concentration of glucose, which is coming from the waste organic matter, is affecting decomposition. You're supposed to explain that. So what does it mean in this context? Use this data provided, concentration of glucose, amount of methane, and that, use it to calculate for us, that is the enthalpy of formation of that. So in this all data, you run it, run for us the enthalpy of formation of, calculate for us the enthalpy of combustion of that, of methane, and you check for us. Then also in a later stage, you go ahead and calculate for us, that is the rate equation based on this data provided. Now, it will be a very fair result at the end of the day to explain for us these two data set here. It will be very easy to explain. You explain for us the effect of concentration on decomposition. I explain for us the effect of concentration on combustion. Then assess the ways through which the use of methane as a fuel can be maximized with reference to the data. So meaning, in this context, how can you maximize, that is, the use of methane? You have realized that the use of methane, what we are dealing with strictly, it is on data table number 2. So meaning, at the end of the day, you reference that data and explain how we can maximize use of methane basing on your rate equation. How can we increase the concentration of the reactants to make products possible? As we have seen that describe them in scenario, and that is concept number 2. How can we reduce on the cooking time? basing on rate equation. That's when now you will have to based on the order of reaction to explain how to reduce on the cooking time. As basic as that. But now, at the end of the day, we shall realize that much of the work uh, on question number 1, it means you are supposed to explain your observation basing on the chemical process you have observed and the governing principle that controls it. So you are going to explain that observation you have seen, then make conclusion on it. Then from then, in part 2, or when we have a block question, like the one we saw with the second paper I've just projected in here, then you will have to explain, like for example, here the question wants us to explain how we can maximize that is use of methane. So it is not requiring, it is also showing us how can we improve the process, how can we improve biogas production, how can we maximize use of methane in this context. So it is requiring you to tell us how to manipulate some of these conditions here which are required in reaction. How can we manipulate conditions involving use of oxygen? How can we maximize conditions, reaction conditions, like for example, in use of methane in that context. So, but if you check in this case properly, the question requiring us to explain how the process can be improved and how we can maximize it. But we might not be able to manipulate condition in this particular item. Now, this guidance differs slightly with item number 2. For item number 2, you will still examine the data, as you can check in here. This guidance to approach on item 2, which is on chemical equilibria, ionic equilibria, colligative, and mole concept. The concept remain the same. So in item 2, we have both physical and chemical process. We might have a physical process or a chemical process. The same idea remains. What differs is concept in item number 3. That for item number 3, remember, the concept with chemical equilibria, ionic equilibria, physical equilibria, they are mainly concerned with how to obtain most of the existing compounds we have in nature for our daily use. Like for example, you find like chemical equilibria, we are trying to do manufacture of many substances from what is already existing in our daily life using chemical processes by manipulating conditions. Ionic equilibria, we are trying to do a lot of work on obtaining substances we can use in daily life. We have solubility equilibrium. We are trying to apply the concept in dyeing materials, a lot of it. Physical equilibria, we are trying to apply a lot of concept here of steam distillation in extraction of organic compound. Colligative properties, we are applying a lot of it in cooling, heating up substances, and etc. And more concept, trying to measure the amount of substances we should use in most of these processes. So at the cost of it, instead of giving that is the evaluation, instead of evaluating or instead of justifying by giving us conclusion and recommendation on how it can be maximized, or a given process can be maximized, or how a given process can be improved, or how a reaction condition can be manipulated. Instead, it will differ in this idea. You are going to explain it as is in part A, the part of assess, examine, analyze the data, go ahead to explain and observe. When the question go to justify or to that justify, evaluate, and all those aspects, meaning you are going to explain how the individuals or society can apply that given chemical concept, which can be a given chemical principle or that given design chemical system to solve real life problem. Like for example, we have in here in the sample paper, they outlined that is they wanted learners to explain, to evaluate the impacts of additive to human life. It's in them two sets of data where they were using different quantities. They were using different quantities of preservatives and different quantities of non-volatile solutes that is in making of juice. And they wanted the one which is recommended with suitable pH, and the one which would have juice preserved for a longer time without freezing. Now, if you need to evaluate the impacts of additives to human life, meaning you should first tell us the good part with it. First tell us the good part with it by explaining how we can apply it in our daily life. You tell us how can we apply the use of additives in our daily life. But the additives you're going to tell us about is what I've talked about in the scenario. The additives we have talked about in here, the benzoic acid, sodium benzoate, and sugar, these are additives. So you explain to us what's the relevance of adding benzoic acid, sodium benzoate. These are acidic buffers. You explain to us that benzoic acid and sodium benzoate mixtures form an acidic buffer we can use in preservation of fruit juices. Then you explain to us how do we do that? Yeah, by controlling the pH to maintain pH of drinks within acceptable pH before they don't get that is spoiled by bacterial action. Now, from then, you will have to explain to us the context here, the impacts of that particular additive to human life. Yeah. But if that only has you to explain its impact to human life, then it will even be a better one. So, in explaining, evaluating the impact or justifying the impact, you will have to explain for us in item number 2. Explain the relevance, then tell us the dangers it is having, that is to the human life or to the society, and give us mitigation for it. So you will tell us the dangers after telling us the importance or the application of benzoic acid and sodium benzoate mixtures in our daily life or in our daily chemical processes or in our daily normal running. You will also have to tell us the impact of it, but through explaining it. Then you tell us the same for sugar. Explain for us the importance of sugar, how we can benefit from it being used as a flavor. Then you explain for us that, then also tell us the dangers associated with it and the mitigation. Those are the ideas we shall be having in justification, and that is in evaluation. The same will run for the rest of other numbers. So coming back to this, what does it mean exactly at the end of the day? What it will mean at the end of the day, that if we ask you to evaluate, it might, in item 1, might mean a different concept. I've told you that in item number 1, let's guide learners to give us, to deduce for us implication of that given chemical process or that given chemical system by giving us conclusion and giving us, explaining to us clearly the recommendation of how a given chemical process can be improved, how yields can be maximized, or how reaction condition can be manipulated to maximize the yield. That's for item number 1. However, this would be a different case with item number 2, as I've told you here. For item number 2, the evaluation we shall have in item number 2, after you explaining the observation for the part of analyze or assess or that or justify, then when they want you to assess the impact or justify the impact or to evaluate the impact, then you will have to explain to us how we apply that given chemical system to solve a real life situation. As basic as that for this item. So this is how we can deal with item 1. Now we can deal with item 2 on physical chemistry, which might be a harder concept to deal with. But for the concept of section B, uh, for the concept of section B, which is, that is on part 1, guidance to approach on item 3 and 4 on organic chemistry. Now, this will be the easiest section that you could actually do, that we can do as teachers to guide the learners properly or in a very easier way. Guidance to approach on item 3 and 4 on inorganic chemistry, which is section B, part 1. When we go and read the question, or before we even go very far, still, how the items are assessed, we shall still have higher order thinking question on assess, justify, evaluate. So all those aspects we shall still have them. So if you have your mock papers, you have interacted with them, you have seen how best they are. But all in all these items are supposed to be cross-cutting. They're supposed to cover a scope of 2 to 3 topics. So my advice to educators or teachers would be, let's try to emphasize students to read all the topics. Let's try to cover all these topics, and we ensure we don't encourage students to cram. Otherwise, if we encourage cramming, then we are going to have cross-cutting topics that students cannot answer. A student will learn on a question they cannot actually answer. We have just seen for item number 2, it had colligative properties, and it had, that is ionic equilibria. So it becomes tough if a student cannot explain the concept why a given substance cannot freeze when it's having high amount of non-volatile solute. So let's try to encourage students to read all topics, to cover all topics, to try to make revision in all the topics. Let's also try to ask to set item basing on this concept. Let's try to set 2 or 3 more variables in the item and make them high order thinking question. Otherwise, if we don't do that, it will be a bad idea for us. I've seen quite a good number of teachers using AI to set. AI might be a better option, but AI might give you a lot of parameters. Like for example, AI can set you up to even 4 parameters at the same time. So when we give you a question or an item with 4 parameters, it becomes very hard to analyze. I'm going to show you an example of that. Most time they put it under chemical properties. It becomes very tough to answer, and meaning that then it has become very hard to deal with. Guidance to approach on items 3 and 4 on inorganic chemistry. When you are presented with inorganic chemistry, which might be a mix-up of different topics, I don't want to run so much on propaganda of how topics might run, or maybe on items 3 and 4, because they can interchange. But when you have mastered your idea so well, and they give you cross-cutting topics, maybe they give you periodicity 1 topics, maybe they are mixing up period 3 and maybe group 4, or maybe they are mixed up period 3 and group 2, or maybe they have set for periodic properties period 3 and some part of group 4. So all those aspects can be combined together, not other than setting only one section. So we have quite a good number of mock papers which are on Space, which are on WhatsApp. I've seen quite a good number. Others have one particular item focusing maybe on a given maybe section like period 3, period 4. I think we can really do much adjustment on that and make it more standard, to make it cross-cutting, to cover like at least 2 topics. It will be a better start to it. But as we try to integrate many topics, let's not forget not to put very many parameters. Otherwise, if we put now like 4 parameters, it will be hard to analyze. So aspect number 1, in the inorganic part, we are supposed to analyze and explain all the physical properties mentioned in the scenario in relation to atomic structure, chemical bonding, and explaining trends and all process of radioactive decay. I was seeing some item on UTech. It had given that is explanation to what a student to explain, that is radioactive decay. One student to explain the properties of radiation. I think I read it sometime back, but if I remember, it had something of this kind on this item of inorganic chemistry. So depending on what you have, like some paper had explanation which was relating, which was in line with chemical bonding. Was in line with chemical bonding and needed you to use the idea of chemical bonding to explain. That is why silicon oxide would be suitable because of having its high melting point. So that would be a physical property in that context. I'm going to project in here, then we see an idea, the same concept. Then we have in here part 2. You're supposed to identify and explain reactivity or all the chemical properties or chemical reaction talked about in the scenario. Now, instead of explaining the chemical reaction, you would be able to write that is the radioactive equations that you would have in that context. Writing up radioactive equations, the part of chemical properties, because those are chemical reactions, they are involving changing chemical composition. Then we have aspect number 3. You are supposed to explain the health or environmental dangers or ethical implication of chemical substances or a given process. Like for the context here, I want to specify strictly the process here for radioactivity and give recommendation or conclusion. Recommendation and mitigation. Now, what does it mean? It means we have very few parameters. It means this area can be the easiest. Number 1, if the question wanted to assess a given idea, the question might be asking you to evaluate, that is the environmental dangers of maybe a given substance. So when they evaluate the environmental dangers or justify the environmental dangers talked about in the scenario, meaning you are going to explain the environmental dangers and give us the possible ways how we can mitigate it. We are explaining it, not outlining it. So aspect number 1, guide learners on how to identify physical properties like melting point, boiling point, density, and predict trends like atomic radius, ionization energy, electron affinity, how to explain strain, the bonding, and etc. All that under physical properties and radioactive process or radioactive decay. Then aspect number 2, guide learners on how to describe a chemical reaction. How to describe the chemical reaction, like by including all the chemical reaction talked about in the scenario. Could have been reaction with alkali maybe wastewater, alkaline wastewater, maybe oxygen from air, maybe reacting with moisture in air, maybe could have been reacting maybe with acidic substances in the waste, which is the acid in the waste. So all these ideas, students should have them. But don't forget, the whole concept still remains describing, that is the reaction speed or reaction kinetics, mentioning all the reactants, mentioning all the products, then writing that is the chemical equation. So those 5 aspects. You mention all reactants, mention all products, mention reaction condition, write equation, and describe reaction kinetics and that is chemical properties. Maybe with exception with radioactivity, where you might not include that. So your role should be, how can I identify physical properties? In aspect number 1, you talk about it. Number 2, identify chemical properties or chemical reaction, talk about it. Aspect number 3, explain environmental dangers or ethical implication of chemical substances or process and talk about it. So, meaning in line with also your setting, meaning your setting should have this 3 items. Fuse us 2 to 3 topics, bind up maybe period 3 and period 3 chemistry and group 4, bind up period 3 and group 2, set up question which are having physical properties, maybe 1 or 2 items, or maybe even 1 item. Put some chemical properties in it which are having maybe 2 to 3 chemical properties. But now, if the parameters are very many, the scenario loses meaning. Then maybe environmental dangers, maybe 2 to 3 items, and now we can mitigate it. This is a basic guidance on inorganic chemistry. In a short time, I'm going to take through, that is on guidance on approach on organic chemistry, because our time is running out. I think I have about, that is 10 minutes on this forum. Guidance on approach on item 5 and 6, that is on organic chemistry. It almost resembles the one of inorganic, but there's be something different with it. On the part of organic, we still have topics. We have question coming from organic 1 and organic 2, but still also topics are combined. We might not set a single topic in a given item. So I think that's the only thing we need to improve for now. Setting up high order thinking question. Then aspect number 2, fusing up topics. We might set alkenes, but the part for organic is not having a lot of challenges. I think the part that is having too much challenge in terms of setting, that I've observed with many mock papers, and many papers that have been circulating is on item 3 and 4. Then on physical, those are the areas that I'm seeing that needs quite a good number of improvement, that I'm very sure with it that teachers will really improve on that, and we shall really have a good outcome out of this assessment. So, first aspect, for organic chemistry, we shall also identify physical properties and explain it. Physical properties like the boiling points of organic compounds, solubility of organic compound, we shall density of the organic compounds. We shall explain all these context and these ideas. But this explanation should be related to the class of organic compound, nature of bonding, structure, which are mentioned in the scenario. So that organic compound mentioned, they say, if they want to explain the physical properties, that is of, or maybe of ethers, you have to explain that. But now, in this context, you should study some of the physical properties of some compounds, like alcohols, ethers, chemical compounds. So, depending on the compound given, then meaning you have to be very flexible in explaining physical properties. So, as you set the scenario, make sure there's a physical property of a given compound or two more compounds you want planners to explain. If items are given, meaning we should look for physical properties and see how to explain them. Number two, we are supposed to analyze correctly the organic reaction scenario, and we using at least two different reaction mechanisms, different reactions. So after looking around in items and look for physical properties, meaning we are supposed to go ahead and look at least two mechanisms mentioned in that scenario, and we write it down. We call the writing, that is how the compound can be synthesized using, that is, arrows. So the arrows, they might not be clearly mentioned, but you will also read the question and see the one-step conversion reaction, which you could see, and you see how best you can outline mechanisms for those reactions. Aspect number three, evaluating correctly the synthetic pathway of organic reaction using correct reagents and that, which is basic of synthesis. Using that is the evaluating synthesis. You're supposed to look for synthetic pathway of all the organic reaction mentioned in the scenario, and you write the reaction, you write the synthetic pathway. Still, we shall maintain use of correct reagents and use of correct condition and all reaction intermediates. We shall still emphasize on all those ones. So at the end of the day, all these compounds we're using have implications we have. So at the end of the day, if you have a block question, meaning these are your concepts you should be following. If you're setting these are the aspects, we expect you to include them. Expect you to fuse up topics, like two to three topics, but ensure the topic you are setting or ensure the item you are setting, you can answer it if we give it to you. So meaning putting too much parameters might not be a good thing. Putting one parameter might not be a good thing. Putting a moderate item, putting a moderate parameter. Like for example, someone is assessing up boiling point, someone is assessing up assessing solubility, someone is assessing state at room temperature. Now those are very parameters. Someone is assessing the Ka value, like becomes too much. Someone has assessed four mechanisms in a similar reaction, then has put like 5 syntheses in a given single scenario. So it becomes so hectic for a student to take in. So evaluating that application, then last one, evaluating application. I told you about evaluation. Evaluation is giving us, that is the real life application of that very particular organic compound basing on its physical properties. How does the physical properties of that given particular organic compound given, or the one we are going to say, how does the physical properties make it be applicable in real life or make it be used in real life? So that is part of evaluation in organic. Then giving us, still you go ahead to give the health danger or the environmental danger or society danger or dangers and you can be exposed to with mitigation. So you really realize that the aspect of evaluation here is almost the same, giving us application of something in real life, giving us, that is, the proposing mitigation, that's giving us the danger, proposing mitigation, or how we can handle that. Like for example, someone can tell you to evaluate, that is the application of ethers in real life, or of esters in real life. So you're supposed to explain to us how physical properties of esters make them be applicable to be used as perfume in real life. You explain, give us some few explanation on that. Then you give us danger associated with use of that. Could be a health danger or societal danger or environmental dangers, and give us appropriate mitigation for that. But all these aspects should be explained. That is a difference with it with O level. Basically, that's what I have for you today. So meaning, if these are the basics of what we have, then you should be knowing your role as a teacher of chemistry, your role as an assessment tool, or like you the person who guide the assessment. You should be knowing your role where you stand. Organic, get physical properties, look at getting mechanisms, look at getting synthesis, look at getting application of organic compound in relation to physical properties. Then look at societal dangers and mitigation and so these are the very aspects we have, unless otherwise someone is having media question. I will invite some few aspects of some few hands from down, then you can share maybe some few aspects before we sign out. My time is up. I'm having in here about 2 to 3 minutes. Those who have questions, you
Thank you very much. Thank you very much, Mr. Chan Nelson, for this elaborate and adequate presentation. We have just heard from you on the assessment of chemistry at the upper secondary curriculum. We are very pleased by this presentation, and I'm very sure that members who are in here have grasped something. I want to be very sure that in this presentation, we were able to understand the elements of constructs that chemistry is going to have its assessment on, because this is very key. But I am very happy that you have helped us to know that the nature of assessment, which is going to be there for the upper secondary curriculum, is scenario-based. Many members have been asking what would be the nature of the assessment, but I've seen in the sample assessments you have given us here, all was purely scenario-based. This is question and answer time. I would like to find out from the members who have been listening to Nelson's presentation, if you have grasped, like me, what are the elements of constructs that assessment of chemistry at the upper secondary curriculum is going to be based? Please raise your hand in the reaction button, and we should be able to share this. Thank you very much. Anyone who is ready to give us the elements of constructs from which assessment of chemistry at the upper secondary curriculum is going to come from, please raise up your hand and we share. I want to believe that my communication is clearly heard. Members, welcome. Some of us are pure teachers of chemistry, others are teachers of biology, but they have learned chemistry and biology. Still, it's very important that this session would help you. So what would be the elements of constructs for the assessment of chemistry? Is anybody here ready to share with us? Yes, please. Get again. If you can't raise up your hand and ask, please write your questions in the reaction button so that we are able to listen to you. Hello? Please, members, unmute yourself and you communicate. Do we have members in the house? I don't see anybody. Huh? Otherwise, Mr. Chan, as we wait for members to think of what they need to ask, there is what we have there in the inbox. I see in the sample papers, there are very many complicated equations. And yet, according to me, I am aware that the lower curriculum did not handle chemical equation writing. I'm also aware of the fact that A-level has only 2 years. I may call it 2 years. At what time are you people helping the learners to do chemical equation writing? And how easy is it? If you may share. Thank you very much.
Thank you very much. That is Madam Betty. Much of the queries you are having, they are really highly addressed because at the level of senior 5, the first thing we do always as the first topic of physical, we handle most an equation. So we expect teachers to take learners through how to write chemical equation and how to balance them for some good period of first term. Secondly, much of the work we are supposed to do with chemical equation, like for example in section A, we always give what we call the support material, that is giving you the chemical equation we want you to focus on. So as compared that is to the previous competence-based curriculum, I mean the content-based curriculum, at least the students are at ease of not doing a lot of work. That is, if you compare with in terms of writing equation and that. But still, what I would encourage us to do, let's try to prioritize as writing equation as well as senior 5, so that by the time we reach here, at least students can compare. That is number of moles in the equation, that is based on stoichiometry, and quite a good number, as basic as that. So that's what I would recommend as teachers to do. Let's try to emphasize how to interpret equation as well as form 5, because both in practical and theory, quite a good number of equation will be shared, that is under physical chemistry. So we might not need to worry much about that. Unless there is another question. Let me hope I've answered you. Yeah.
Thank you very much, Mr. Chan. That was my real worry. because I can recall as I was studying chemistry, writing of chemical equations, they started it way back in senior 1, where we were guided through word equation and so on. But now learners are to go and do it in senior 5. I was imagining how difficult it could be if we would spend a lot of time understanding how it is. But with your guidance, I am very sure that we are almost there. However, I had asked members present in this discussion that what have they learned, what have they understood about the elements, which are the areas that assessments are going to come from. You try to guide. I didn't pick it very clearly. In total, how many assessment question items are there for chemistry? And which areas are they supposed to come from? I was hearing you say, is it assessment item 1, this and that, is it supposed to be combined, something like that. I don't know if you have a summary of it so that we would present it here and members walk away with it. Thank you, Mr. Chan.
Thank you very much, artist Madam Betty. I specified that we are going to be having total of 6 items. And I remember saying we're going to be having 2 compulsory items from section A. That's what I presented earlier, and that's in the paper structure. Then I said section B, we're going to have a total of 4 items. 2 are going to be coming from
Wait, sir. The 2 compulsory items, do they have specific areas where they would be coming from?
Yeah, and I got it on that. I said earlier that the 2 compulsory items, they will be coming from the first item that is on section A will be coming, that is from thermochemistry, electrochemistry, and chemical kinetics. Then question number 2, that is item 2, still under physiochemistry, will be coming from, that is equilibria 1, equilibria 2, and moles and equations.
Oh.
Then I also went ahead and guided on paper structure on section B. That section B will have 4 items. And I remember saying 2 will come from inorganic chemistry, then 2 will come from organic chemistry. And a learner is expected to pick 1 from each part. And all these items are blended.
A total of 4 items have to be answered.
Yeah, a total of 4 items will have to be answered. Yeah.
In how long? 2 hours, 30 minutes, 3 hours?
We'll take that is 2 hours and 45 minutes, as I told you earlier. Yeah. The time allocation is well allocated. That is on the question. Yeah. Supposed to take that a total 2 hours and 45 minutes. Yeah.
I'm sorry, Mr. Chan, if I keep taking you to what you had already talked about. For me, it is areas of emphasis because we have to walk out of this discussion when we are very sure of what happens. You have told us that chemistry is going to have a total of what? 2 papers only, right? Paper 1, which is theory, and paper 2, which is practical. Am I correct? And what would be in the composition of the practical paper? Hello, Mr. Chan.
I'm getting you.
Yes, please.
I'd prepare, that is to discuss, that is the basics of paper 1, but still practical. We shall be having 2 items. We shall have strictly 2 items. The one which is involving scientific investigation and the one which is involving, that is qualitative analysis. So basically like that. So we might be having physical, which is involving scientific investigation, and we shall have interchanging of organic and inorganic and the qualitative analysis. Yeah.
Okay. It's because I did not hear that part clearly. I'm sorry that I had to bother you explaining it again. Yeah. So members, this is what we have for tonight. I know there could be other questions that we still prepare to ask. I've just started discussing assessment items. We finished ICT. Today we have been for chemistry. I don't know, for next week we may go for mathematics. And I would like to encourage members, please come when you're ready to ask as many questions as possible, because the facilitators we are bringing here are people we have confidence in, and they have researched widely on these assessments. So there have been questions we have been asking ourselves, and this is the forum where I would expect that we are able to ask as many questions as possible. For today, I don't see any other person interested in asking question. And I would like to say that thank you very much, Mr. Chan. Thank you for offering for us your time and doing a lot of this research to help us be where we are. I wonder if there is anybody who wants to have any other communication apart from the discussion we have been having. I am still ready to give you room.
Maybe, yes, Madam Betty, thank you very much for the moderation, and Mr. Chan for the discussion. I've actually been hearing you're very, very, very knowledgeable on various aspects of chemistry. These sessions are very resourceful, and I would like to encourage the members on that let us share. We have even our learners in holiday. They can join in and they get some of this. I'm aware government has was discouraging holiday studies. So I know most of the students are at home. Yeah, so I think we can go through some of these areas. Even next week, yeah, we look at the structure. So the things we are discussing we are published on first of all, NCDC came up with what we call assessment frameworks. They are on the website of NCDC. In each of these frameworks, there are things like the assessment items, the constructs, now like this one of chemistry, what Madam Mama was asking for, the constructs, the structure of the paper. So this was as at what NCDC had put together. But then after that, UNEB digested this more and came up with assessment, sample assessment, where there could be some few adjustments here and there, but still most of the things are still in line. So by getting people like Mr. Ochan to come and discuss this and give guidance, it helps. The videos are recorded and are captured on YouTube. So even other colleagues who have not managed to attend, they should be able to get the recording. And then we continue. And also on our website, UPSTU.org, can be able to access the resources that we shall be putting there. Yeah, so thank you very much, Madam Auma. That is what I wanted to comment on this.
Very grateful, Rogers, for this compliment. Thank you very much, Mr. Chan. Once again, I wonder if you maybe have one or two words you want to conclude with. You're welcome.
Thank you very much, as Madam Betty and all that is the leaders of that is of the science, that is Uganda professional science teachers. My only word that is I would like to extend, or my words I would like to extend to teachers are like, let's try to follow up these guidelines and see our best, because if we don't set standard items, then we are going to take a lot of time to make students get what we are supposed to get them from this assessment criteria. Otherwise, if you don't follow up this guideline from the assessment criteria and the paper structure, it will be very easy for us to keep on following when we have the standard papers at our doorstep. So let's stick to this assessment framework. We try to develop items that have all these qualities, and will help us do the best and get the best from our learners that we have. Thank you.
Oh, thank you very much, Nelson. Thank you for your time. Thank you for this. And thank you every member here at your various capacity for having joined today's ProDev Hour. Next Thursday, we shall have yet another fruitful discussion. I encourage us to come back and we continue this continuous professional development hour that has been created by Uganda Professional Science Teachers Union. I would like to say that may God bless all of us. and we have a good night as we attend to holiday makers. I know at least each of us have somebody who has come back from school. Let us encourage them to keep revising as they're at home. I said this for God and my country. Have a blessed night. Good night.